Yes. What is the formula of long chain alkane? This is only addition. Only addition of C C2H4 2 C2H4 plus C4H10.
I don't know, teacher.
Oh, maybe okay. Christopher. Hello, Christopher.
Yes, hello.
Hello, all. Christopher. So, what is the answer when uh, long chain alkane undergo cracking to form two ethene and one butene? In fact, two ethene is two C2H4 plus one C4H10.
Um, is it C8H18?
Yes, correct. C8H18. And then next, district chain alkane found in the petrol fraction which contains the lowest percentage by mass of hydrogen. Refer to the table at the start of the question to deduce your answer. Okay, it has the lowest percentage of hydrogen. Which one has the lowest percentage of hydrogen?
Mm,
Yeah. Let me ask to uh, Christo.
yeah,
Can you answer, Christo?
is it C12H26?
Yes, correct. C12H26. It has the lowest hydrogen by percentage. Number four. Number four. Central heating fuel is obtained by distillation of crude oil. Central heating fuel. What is central heating fuel? Is this one, gas oil or diesel. Okay. Contains 16 carbon atoms per molecule. When a molecule of this alkane is cracked, propene is formed. Name the crude oil fraction used as the central heating fuel. It is called as the gas oil or diesel. And then number 2. Write an equation for the cracking of 16 carbon alkane to form octane, propene, and ethene as the only products. Let me ask to Devin. Devin Hartanto. What is the equation? Can you tell? Hello, Devin.
Hello,
Yes,
teacher.
Devin. What is the equation? Can you tell us when
C
carbon? Yes.
C16H34 ya.
Yeah. Becomes.
Become C8H18
Yes. Plus.
plus 2C3H6
Yes. Plus.
plus C2H4.
Yes. Correct. Now, uh, give one important commercial use of propene. Let me ask Adeline. Hello, Adeline. Are you there, Adeline?
Yes, teacher.
Yeah, give one important commercial use of propene.
Um,
What does it use for?
it's used for production of chemicals
Okay,
like
production of chemicals such as polymers.
pro-
Okay,
Yeah.
making plastic, PTFE. Also, it is used, and then uh, polypropylene also. Then next, B, a catalytic converter in the exhaust system of a car contains ceramic honeycomb covered with a thin coating of the catalyst. When hot gases containing nitrogen monoxide and unburned octane are passed over the catalyst, they react to form nitrogen, carbon dioxide, and water. Catalyst use, we explain what catalyst is coated with honeycomb. It is because, let me ask to Hansen. Hello, Hansen. Was it covered with honeycomb? Hello, Hansen Suhanto. Are you there? Oh, maybe busy. Let me ask Jalen. Hello, Jalen.
Hello.
Yes. Explain why the catalyst is coated on a honeycomb.
I think it's because it has a really large surface area,
Yeah. Therefore,
and I think the reaction is also much faster.
yes. Okay. Correct. And then number two, second point. Write an equation for the reaction of octane with nitrogen monoxide to form nitrogen, carbon dioxide, and water. So the equation is C8H18 plus plus 12 plus 25 NO plus 25 moles of nitrogen monoxide to form 8 moles of carbon dioxide plus 9 moles of water and plus 25 by 2 nitrogen gas. Okay, and then for the for the last page, this one, number 5. Gas oil, kerosene, mineral, and petrol are 4 of the 5 fractions obtained by fractional distillation of the crude oil within temperature range 40 until 400. Identify the missing fraction. The missing fraction is naphtha. Give 2 reasons why the fraction collect at different levels in the fractionating column, because they have different boiling points. They have different boiling point. Okay, and then uh, give state in order in which the 5 fractions as are removed as the fractionating column is ascended. So the order is lubricating oil or mineral oil, and then the second is gas oil, and then there is kerosene, and then naphtha and petrol. Okay, next, B. The thermal cracking of large hydrocarbon molecules is used to produce alkenes. State the type of mechanism involved in the process. Write an equation for the cracking of C21H44 in which ethene and propene are produced in 3 to 2 molar ratio together. So here the thermal cracking, the mechanism is free thermal cracking of the this one mechanism is homolytic fission. The thermal cracking, homolytic fission, it is the formation of free radical substitution, and then the cracking of C21H44. So here C21H44 become 3C2H4 plus 2C3H6 plus C9H20. Okay, so and then write an equation where appropriate to illustrate your answer in the questions below. Explain why it is desirable that none of the sulfur containing impurities naturally found in crude oil present in petroleum fraction. Um, it is non-desirable of the sulfur containing impurities. So sulfur, when sulfur is the natural, is naturally it is not desirable because when petroleum burned or combusted, the sulfur will produce sulfur dioxide, which is cause the acid rain. And then C2, pollutant gas, nitrogen monoxide, is found in the exhaust gases of petrol engine. Explain why nitrogen monoxide is formed in petrol engine but not readily formed when petrol burns in the open air. Nitrogen monoxide is burned because around 80% or 79% of the air is nitrogen. It goes into the engine in which the amount of oxygen in the engine is limited. So when nitrogen is heated, nitrogen will combust with limited amount of oxygen to produce nitrogen monoxide. But when petrol burns in the open air, there is an excess amount of oxygen. When nitrogen gas is combusted in excess amount of oxygen, nitrogen monoxide will be formed. The third one, the pollutant gas, carbon monoxide, is also found in the exhaust gases from petrol engine. Explain how the carbon monoxide and nitrogen monoxide are removed from the exhaust gas and why the removal of each of them is desirable. The this one, uh, pollutant carbon monoxide, how carbon monoxide and nitrogen monoxide removed using catalytic converter, which is the presence of palladium platinum catalyst. The reaction is nitrogen monoxide will undergo oxidation to form nitrogen dioxide, and then nitrogen dioxide reacts with water to form nitric acid, and then uh, carbon monoxide will also be removed in catalytic converter. It will undergo oxidation to form carbon dioxide gas, and carbon dioxide can be reduced in the process of photosynthesis. And then why the removal of each of them is desirable. Carbon monoxide is dangerous. It is cause carboxyhemoglobin. It is poisonous. And then nitrogen monoxide is also dangerous. It can cause global warming. Okay, so these are the discussion for AS level. I hope you don't have any
Okay.
question on this. If you have any question, you can ask on the Google Classroom. Okay.
Teacher, teacher.
Yes, you can go to toilet, Hansen.
No, I said that before when you call me, I think.
Oh, okay.
That's why.
Okay. Okay. So now, after finish discussion with the AS level, I'm going to discuss questions with A level. Okay, so for AS level or minor, we are going to have the chemistry test on this Friday, chapter alkanes. And then next week, we are going to start with alkene. Okay, so good morning, students. So let me start with the major. For the AS level, if you want still continue, in this discussion room, you're welcome. If you want to leave, also you are welcome. Okay. Now going to stop sharing this one. Okay. I'm going to share another. Hello, Pimo. It's a nice hairpin, Pimo.
My hair too very long is very long. It's
Yeah, my
too
hair is
long.
also very long. I do not want to go to barber shop.
Yeah, I just got it cut.
Okay, yesterday we were until this part. B. Polyester's third page. Polyester was produced by reacting a diol with diacyl chloride. The repeating unit of the polymer is shown below. Name the diol used.
1, 2, 3, 4, 5.
Penta
Pentiol.
Pentadiol.
Yes?
Pent 15 diol.
Yeah. 1.5.
5.
1.5 diol.
Yeah, correct. Okay. Uh, and then for this one, draw displayed formula for diacyl chloride used.
Diacyl chloride. So
Yeah,
COOH, CH2,
So-
CH2, COOH.
diacyl acyl chloride become
diacyl chloride.
COOH,
wait.
CO,
What you call? What is the suffix for acyl chloride again?
Suffix is Cl.
methyl methyl.
Oh, acyl chloride.
Or just
Acyl.
acyl chloride?
Yeah. At
That one is
acyl is
1.
2-acyl chloride.
That one is
Mm,
COH, CH2, CH2, COOH, right?
C. So it is forming like 2Cl on both sides.
I mean COCl.
So
F
there's
dioyl chloride.
Cl here,
COCl,
So
and then there is
CH2, CH2, CHCl.
bond
it becomes
C, and then there is a
C double bond O.
O, and then here
CH2, CH2,
yeah,
CH2.
C2H4
Mm-hmm. Good
4,
enough.
and then C double bond O, and then Cl. Yeah. A shirt was made from this polymer. A student wearing the shirt accidentally splashed aqueous sodium hydroxide on a sleeve.
That's not good.
Holes later appeared. Holes appeared in the sleeve where the sodium hydroxide had been. Name the type of the reaction that occurred between the polyester and the aqueous sodium hydroxide.
Hydration.
It is
Hyd hydrolysis, not hydration.
hydrolysis. Okay, so the type of the reaction is hydrolysis, and then uh, explanation. Why is there hole?
The explanation.
Yeah,
Uh,
the polyester. This one.
let me get my little worksheet here.
Yes.
Okay. The ester reacts with hydrogen and have So it returns into a carboxylic acid and alcohol.
Yeah.
Then since acid and alkali, so the
Yeah.
alkali which catalyze the previous reaction will react with the carboxylic acid,
Yes.
which turns it into a H2O and the salt of the carboxylic acid.
Yes, correct. Okay, now C number 1. Complete the following equation. Complete the following equation for the preparation of aspirin. Aspirin following using ethanoic anhydride by writing the structural formula of the missing product.
That is aspirin, right?
Yeah,
Oh boy.
this is aspirin.
Oh boy. Let me see this. Look at this first.
Ethanoic acid.
I may have an idea on what it is.
Yeah. Okay.
I have no idea at all for the
I think CI is
mechanism.
ethanoic acid.
I may have an idea on what it is.
Yeah, it is not difficult, Julie.
I guess it's C2O. Not sure.
Yes. The first, okay. Hmm. It is not uh, ethanol. Ethanol doesn't react with carboxylic acid to form acid anhydride. It must be two carboxylic acid. Must be two ethanoic acid react to form acid anhydride. Is this O?
Yes, that is an O.
Oh yeah, correct. This is the structure. Okay, so form ethanoic acid. Suggest a name for the mechanism for the reaction in C part 1. What is the mechanism?
The mechanism.
Yeah.
Condensation.
No, cannot be condensation, bro.
Uh-huh.
Hold on, yeah, hold on.
Yeah.
H is removed from OH, so OH, O give its electron to H, or no, H
So
gives its
I think
electron
it's
to that. In here, since O is more electronegative, C.
There are two mechanisms here. Look at the structure. From the structure, there is the this one of the
I
H
see
is gone.
nucleophilic substitution.
The
Yeah.
H gone because it gives its electron to O.
I say
Yeah.
nucleophilic
So it
substitution.
becomes
Correct.
a electrophile.
Oh, it's electrophile.
The thing that reacts though, the one that's going to the reactant should be this
Nucleophile.
thing.
Nucleophile.
Yeah.
Oh
Nucleophile.
yeah, it wants. Never mind. Yeah, it is a
I thought
nucleophile. It wants it.
because
Wait, I don't get that.
the H3C
This
double
one,
bond ONO
this hydrogen is
taking an
removed,
electron.
and then this O become negative,
Negative.
Negative.
So it has electrons and wants a
and
proton.
then yeah, and then there is this one. This one is removed.
Giving the
This
electron to
one,
O.
this one,
Electron is taken in by oxygen.
yeah,
addition elimination.
The electron of carbon is
and
given to
then
oxygen.
this
Positive.
one become positive, and then the electron here, the electron on the O from here
Oh,
goes
I get it now.
here, and then so it combines. So nucleophilic.
Nucleophilic
Okay.
addition, substitution, right?
Yeah. And then number three. Number three.
Oh yeah, teacher.
Yes.
For the reactants, that one kan they are apa symmetric, right? That means it can react either with the top or the bottom, right? Up to us.
Which one? Symmetric.
The one that
Oh,
have the
yeah.
benzene ring.
Yeah.
Okay.
Sir, I have one more question.
Yes.
Which one is the reactant here? Because if the second one becomes the reactant, then it becomes if this one becomes the reactant,
Electrophilic, right?
it becomes yeah. So which one is better? This one, which one should
This
become the reactant?
this one become negative. There is an excess electron that can donate.
Mm-hmm.
Yeah.
But then if this one becomes the reactant, right? This one that
Yeah.
I'm pointing right now.
Yeah.
But if this one becomes the reactant, then it becomes nucleophilic, right? Because this one's a nucleophile.
Yeah.
So I don't know which one, how to determine which one becomes the reactant, which one becomes the substrate, or
Now, both of them are reagents. Both of them are
Reactants.
reactants. So we have to see. Oh, this one become negative, and then this one is added to it.
so
Yeah.
we have to look which one is the one that's
Yeah.
added.
Yes. Okay. Now let's see this one. Next question. Give two industrial advantages other than cost using ethanoic acid anhydride rather than ethanoyl chloride in the production of aspirin. In ethanoic anhydride is it is not corrosive, okay, and then it is less dangerous than ethanol chloride. We know that acyl chloride is much more reactive than carboxylic acid. Ethanoic anhydride is the reaction of two carboxylic acid. We know that 2-carboxylic acid is unreactive compared to ethanoyl chloride.
All right.
Yeah, so these are the two advantages.
The first one is because it's less corrosive. Second one is
Yeah,
because it's less reactive.
yeah. Actually, the basic is they are not reactive, but not reactive. First idea, the first idea, if not reactive, it means it is not corrosive. If it is not reactive, means it is not easy to hydrolyze. If not reactive,
Mm,
means it is not easy to evaporate. Because if reactive, it means it is easy to evaporate, easy to react, easy to
I see.
cause something to rust. Okay.
Okay, I see.
Number D, complete the following equation. Complete the following equation for the reaction of one molecule benzene 1.2 dicarboxylic anhydride phthalate anhydride with one molecule of methanol. One molecule of methanol. What would be the product? What would be the product?
One molecule of methanol.
Yeah.
Hmm. This is a very, very odd question.
So there is this one. Sorry if my benzene ring is not perfect.
No problem. No problem.
And then this one, there is carbon. and there is so carbon, and then this one there is a double bond O, remain double bond O, and this one there is a carbon also, and then this one the double bond O remains. Double
Yeah,
bond
they're
O
too stable.
remains, but this one is the difficult one. Now one of them, this one become OH, and then when this one become uh, O
CH3OH, CH.
CH3. Yes,
So one of them become ester, the other one becomes carboxylic.
yes, correct. So because of this benzene, if not because of benzene, that become carboxylic acid.
Okay.
And then E, the indicator phenolphthalein. Last time in school, we always use phenolphthalein, but we do not know what the structure is.
This is the structure.
Yes, phenolphthalein indicator is synthesized by reacting phthalic anhydride with phenol as shown in the following equation. Okay, so this one there is a phthalic anhydride and there is a phenol with concentrated sulfuric acid. If there is this kind of indicator, this one, it means this is what reaction? Do you still remember? Grade 10?
Then
Purification.
Concentrated sulfuric acid.
Yes,
It doesn't that mean
it is
with
ester.
yeah, esterification, right? Because
Yeah,
there's
esterification.
carboxylic acid.
Yeah. So this one will form esterification. Become an ester. COO. Yeah.
But then the thing's just ester, right? Without
Yeah.
the that's just a normal ester. Yeah.
Yeah. This is the ester linkage, and then name the functional group ringed ester, of course, and then next this one deduce the number of this one in spectrum, no need, because
Oh no.
you have not learned about the spectrum
Yeah.
phenolphthalein. Okay, now phenolphthalein can be used as indicator in some acid alkali titrations. The pH range for phenolphthalein is 8.3 until 10. For each alkali combination in table below, put a tick if phenolphthalein could be used as indicator. Do you still remember
Yeah, I think so.
about acid, strong alkali, strong acid, weak alkali, and weak acid, weak alkalis, weak strong alkali with weak acid.
Mm-hmm.
This one, sulfuric
yeah.
acid and sodium hydroxide, is strong acid and strong
And
alkali.
strong
Can,
alkali. So
can
I
be
think
used.
can be used.
Yes, can. It is can. And then strong acid and weak alkali.
Don't think so.
Strong acid and weak alkali. Okay. What is the maximum pH range of phenolphthalein, Nicholas?
8 to 10.
Yeah, 8 to 10. If strong acid and weak alkali, what would be the final pH?
If strong acid and it will become acidic, right? If added together.
Yeah, become acidic. And then ethanoic acid, and then weak acid and
Strong
strong
alkali
alkali.
becomes cannot. It will become alkaline.
Oh,
Now, become alkaline is pH between 8 to 10. So this one can. Strong acid strong acid, methylamine. What is methylamine? Strong,
That is a
strong alkali or
weak
weak
acid.
alkali?
A weak alkaline.
Weak alkaline.
Weak alkaline. So cannot. So only this two. Okay.
Also, when it's like when they are mixed together, will they form a substance with the pH between
Yeah.
8 until 10, like that?
Yeah.
Oh, okay.
Okay. And then now in titration, nitric acid is added from burette to a solution of sodium hydroxide containing containing few drops of phenolphthalein indicator. Give the color range at the end point. Nitric acid,
Pink to
acid to
colorless.
alkali. Yeah, acid to alkali, not alkali to
Oh,
acid.
colorless to pink. Colorless in the acid, then pink because it's pink in the alkali range. So colorless to pink.
Yes, correct.
Oh, is it pink in alkali or pink in acid? I forgot.
Pink
Ah,
in
pink
alkali because
alkali.
the easy way to remember is like this, Los. Kan in universal indicator red to purple.
Yeah.
Just remember that and you'll be fine.
Yeah.
Okay.
Same thing with methyl orange. In alkali it should be green, but in acid it should be orange.
Yes,
Oh, yeah, I get it.
Nicholas is
Okay.
correct. And then number 3, the amide or peptide link is found in synthetic polyamide and also in naturally occurring proteins. Draw the repeating unit formed by the reaction of propane dioic acid with hexane 1.6 diamine. I'm sure you are able to draw this one.
Probably.
Propane dioic acid and hexane 1,6 diamine. Yeah.
Yeah, you can. I'm sure you can draw this one. It's not a problem for you, right? And then
Yep.
yeah, okay. And then in terms of the molecular formula, polyamide used in sewing polyalkanes. This one usually produce fibers that are too weak for this purpose. Okay. What is the intermolecular forces between polyalkylines?
Van der Waals. Well, polyamides can do what you call it, the hydrogen bonding.
Yes, correct. Polyamide can do hydrogen bonding, and then the
Polyalkenes are not possible to do that.
exactly.
Only Van der Waals.
Yeah. For this one, the mechanism between this one propyl chloride and with methylamine.
Esterification. No. Yeah,
Condensation.
esterification in with acyl chloride.
Yeah, esterification.
Huh? This one esterification?
Hold on.
No, it
Esterification.
is not esterification.
Hold on a minute. Something feels wrong.
Because it COs and H, not
Yeah.
CO.
Hold on.
CONH become CONH and
Right.
SHCl.
So that means it's
Nucleophilic substitution.
Condensation.
mm,
What was the name? I can forget. Yeah.
It will become
uh
amide.
Condensation.
You still remember? This one is the amide.
oh yeah, it is an amine. That means
Amide between this one and also sorry, this one,
so if that happens,
the hydrogen will be removed. One hydrogen removed, so become R C double bond O and then N H CH3. So this become amide. What is the mechanism?
Um,
Type. Is it called? Yeah.
oxidation.
Oxidation? No.
Oh wait,
Oxidation is
oxidation
reaction with
is.
oxygen.
Hmm.
It is
Please don't tell me it's a reduction.
it is
One minute.
addition.
Just addition. Oh, okay. So that means this is
And there is elimination.
Addition, elimination.
Eliminate the
uh,
this one. Eliminate the chlorine.
so that means it's substitution.
Exactly.
And
What
if
substitution?
so this becomes nucleophilic substitution.
Exactly. So
And
too many reactions already get confused.
oh yeah, because the Cl, yes,
Yeah.
nucleophilic.
And then this one, okay, because it's already almost the time, I do not want to take your time in other class. So tomorrow we'll discuss the rest.
Again.
Yeah, the rest, and I will add new worksheet tomorrow morning.
Okay.
Oh no.
Oh
Okay,
no.
My God.
I'll see you again. I'll discuss with
Bye,
you
bye,
tomorrow morning.
teacher.
Okay, good morning.
Yeah, thank you,
Thank you,
teacher.
teacher.
Morning
Have a
and
nice
thank
day,
you,
teacher.
sir.
Thank you, teacher.